For 10 meter cube tank filled with saturated R134A vapor at 0 degrees C. After some time, tank gets heated up to 30 degrees and we want to know the final pressure. So we've got a tank, we can assume it's a rigid tank because we have a fixed volume, 10 meters cubed. Let's say that's volume 1 and volume 2. At time 1, it's saturated vapor. So let's put the things for time 1 here. I know it's saturated vapor. I know it's 0 degrees C. What else do I know? Not much. It's R134A. And then at time 2, I know that it is 30 degrees C. That's about it. We want to know the final pressure. So the trick here is to define state 2, right? Whenever you are interested in a property, you always think in those terms. Just think of, okay, how do I define state 2? By defining the state, I mean getting your two independent intensive properties that you can go to the tables, use the rules in that property reference sheet to find what you want. In this case, what we want is pressure. What we know is 30 degrees. That's not enough, right? We need two things. And so we're going to go use this again, the volume, because we know the volume is fixed. We know that it's 10 meters cubed at time 2, but we don't know the mass, right? So we can't just calculate the specific volume at time 2. But we do know volume didn't change between 1 and 2. Mass didn't change between 1 and 2. And so that means specific volume could not change between 1 and 2. So we'll look up the specific volume at time 1, and then we'll use that specific volume at time 2. So specific volume at time 1, 0 degrees, saturated vapor, R134A. So we need to go to the table organized by temperature, which is table A11. Find 0 degrees C. Says the specific volume is the property we're interested in, right? Because that's the one that's constant. And we have saturated vapor, so we need VG. It's 0.069, so volume 1, 0.069255 meters cubed per kilogram. Okay, that's specific volume 1, also specific volume 2. Because it's the rigid tank, we'll just go 0.69. That's enough. So now we need to determine the phase at time 2. We don't know what it is at time 2. So if we go there, go to 30 degrees, because that's the thing that we know, and compare this specific volume to VF and VG in order to determine the phase. VF is 0.000 something. Ours is bigger than that. VG is 0.026. Ours is bigger than VG. So again, that means superheated vapor. Go to the superheated vapor tables. Now we have a little bit of a problem, sort of a strange thing here, because we don't know the pressure. That's what we want. The superheated tables are organized by pressure. That's where you want to start. And that's not possible, but we do know that we have the combination of 30 degrees and that specific volume. And so if we look at 30 degrees, just pick any pressure, doesn't matter. Compare this specific volume to the specific volume at 30 degrees at that pressure. It's not going to match. So then we'll go to another pressure, and we'll either get closer or further away, and then we can kind of hone in on it. I'll just pick 0.4 megapascals, 400 kilopascals. That's my first guess. So I'm going to go to 30 degrees, and the specific volume at 30 degrees and 400 kilopascals is 0.0567. So we're not far away, but we're not on. So now I'm going to go to the next lower pressure, so 0.32. 30 degrees there. Specific volume is, let's see if I can go straight across, 0.0723. So actually, we went right around it, right? Because at 400 or 0.4 megapascals and 30 degrees, we had, what was it, 0.56, 0.56 something, and at 0.32, I'll put it above because it's smaller value, in 30 degrees, we had 0.0723. Our value is 0.069, which fits right in between there, closer to the 0.32. And so if we want to estimate, we can say, what's that look like? It's quite a bit closer, so it's maybe 0.3435. And that's megapascals. Same as 340 kilopascals. Again, it depends on what kind of pressure or what kind of precision we're interested in our answer. If we care about this because we're buying a storage tank, we calculate this and we know our tank's rated to 1 megapascal, we don't need to interpolate, right? We know that we're safe. It's, you know, it's this plus or minus maybe 20 kilopascals. If we need to know really precisely what that pressure is, then we can interpolate. Just set up this ratio, 0.32, the pressure we're interested in, and 0.4, and then put this value in here, and then you do this minus this, divided by that minus that, and then the same thing over here, set them equal to one another,